Hey, what is up guys? Welcome to another video. In this video I'm going over Higher Paper 3 from the Edexcel Maths GCSE papers from November 2017. If you're after the paper, I'll link that in the description. So definitely have a go at that before watching this video if you haven't already. And my best advice to revise with past papers is to treat them as an exam. So give yourself a time limit, turn your phone off and be really strict with yourself for an hour and a half to test what you know. Afterwards, mark the exam. This helps identify where you need to improve. By the way, thank you to those that are liking my videos and leaving positive comments, especially when I get comments from students saying their results are improving or the video was helpful. It's really nice, so thank you so much. Other than that, let's get straight into it. Question 1 says, the table shows information about the heights of 80 children. Find the class interval that contains the median. So you know about the mean, median and mode, and the median is the middle value. So if you have a list of numbers, then the median will be the middle value in that list of numbers. So here we have 80 children, so we need to find the middle of those 80 children. And to find the middle value of anything, you can say the median value will be n plus 1 divided by 2. So that gives you the median of the middle value of this list of numbers. So if we take 80, add 1 divided by 2, that will give us the median value. And so that gives us 40.5, or the 40.5 value. So in this list of values, we have 80 children and we need to find the 40th and the 41st, and they will fall inside the median class. So here we can see the first 4 children were between 130 and 140 centimeters. The first 15 children, if we add these up, will be between 130 and 150. And then the first 39 will be between 130 and 160. So if this is 39 children up to this point, the 40th child and the 41st child must fall into this category here. So we can say that the median class is 160 to 170. Part B says draw the frequency polygon for the information in the table. So the key thing about frequency polygons that you need to remember is that we plot them at the midpoints of the intervals. So if we take this frequency of 4, we need to plot it halfway between 130 and 140, so at 135. So all of these midpoints will be 135, 145, 155, 165, 175. And then we just need to plot the frequencies. So we've got 4 at 135, then we've got 11 at 145, then we've got 24 at 155, and then 22 at 165, and 19 at 175. And make sure to join the graph up to the axes. And there's your frequency polygon, and that's for 2 marks. Question 2 says, in London 1 litre of petrol costs 108.9p. In New York, 1 US gallon of petrol costs $2.83. 1 US gallon equals 3.785 litres. 1 pound equals $1.46. In which city is petrol better value for money, London or New York? You must show you're working. So here we need some equivalent ratios we can compare. So at the moment we've got a ratio in pounds, so we can say 1 pound and 89 pence is 1 litre. And also in the US we've got $283 is equivalent to 1 gallon. And we need to compare these somehow. So I'm going to change this ratio into pounds per litre in order to compare it with the cost in London. So the first thing I need to do is change these dollars into pounds. We can do that using ratios. So 1 pound over $1.46 should equal, if this is pounds on the top and dollars on the bottom, this should equal the same as however many pounds I have, let's say just X, is equal to $2.83. So what I'm looking for here is the amount of pounds that I need. So what I can do is I can just divide 283 by 146, then I get X equal to £1 and 938,356 etc. cents, and I can round that off to £1 and 94 pence, and that equals $283. Okay, and then what I need to do is to change the gallons into litres as well. So 1 gallon, well, that's already done for me. I know what 1 gallon will be, 3.785 litres. So I have a new ratio. This is going to equal £1 and 94 pence per 3.785 litres. So to change that into 1 litre, I need to divide both by 3.785. So if I divide 1.94 by 3.785, I get 0.5125 approximately. So my new ratio for New York is basically 51 pence per 1 litre. Okay, so that's definitely cheaper than London. Basically 50 pence compared to £1 per litre. So then I can say it is better value. It is better value in New York. Okay, that's for 3 marks. Question 3 says a gold bar has mass of 12.5 kilograms. The density of gold is 9.3 grams per centimeter cubed. Work out the volume of the gold bar. Give your answer correct to 3 significant figures. So you might have seen this triangle before, comparing mass, density, and volume. And it looks like this. So mass is on top, density and volume are on the bottom. So what this says is mass equals density times the volume, and volume is the mass divided by the density. So here we're looking for the volume, so we take the volume and we can say that equals mass divided by density. So here we've got the mass in kilograms, and we need them in the same units. So we could change 12.52 grams, and that will be 12,500 grams, divided by 19.3 grams per centimeters cubed. And if we do that calculation, we get 647.668. And if we can round that off to 3 significant figures, this one's the 3rd significant figure, so we round that off, and that would be 648 centimeters cubed. And that's for 3 marks. Question 4 says there are only blue pens, green pens, and red pens in a box. The ratio of the number of blue pens to the number of green pens is 2 to 5. The ratio of the number of green pens to the number of red pens is 4 to 1. There are less than 100 pens in the box. What is the greatest possible number of red pens in the box? Okay, so let's firstly write down these ratios. So we've got blue to green equals 2 to 5, and then green to red equals 4 to 1. Now what we can do is we can compare these combine these ratios by finding a common multiple of green pens. So if we have a look here, we've got 5 to 2 for the ratio of green to blue, and 4 to 1. If we can turn this number into the same multiple, we can combine these ratios into a ratio that compares blue, green, and red. So the lowest common multiple of 4 and 5 is 20. So if we say the green pens in this ratio is worth 20, then we need to multiply. What we've done is we've multiplied this ratio by 4, and we've multiplied this ratio by 5. So 2 times 4, that's going to be 8, and then 1 times 5, that's going to be 5. So the ratio comparing all of the pens together will be 8 to 20 to 5. Now, the second part of this question says there are less than 100 pens in the box. If we add up this ratio, that gives us a ratio of 33. Now I can multiply that by 3 and still have less than 100 pens in the box. So if I multiply each number in this ratio, that's going to be 24 to 60 to 15, and what this is saying is there were 24 blue pens, 60 green pens, and 15 red pens. So the greatest possible number of red pens in the box, that must be 15, because this is the highest possible ratio that we can have. Question 5 says, find the value of the reciprocal of 1.6. Give your answer as a decimal. So the reciprocal is what we can multiply by that number to get 1. And the easiest way to find the reciprocal is to divide whatever number you're given by 1. So if we say 1 divided by 1.6, that gives us the reciprocal, and you do that sum and you get 0.625. Okay, the second part of this question says, Jess rounds the number x to one decimal place. The result is 9.8. Write down the error interval for x. So we need an error interval here, and x is going to be greater than something or less than something. So what rounds to 9.8 to one decimal place? Well, that could be 9.75. That rounds up to 9.8. And it could also, x could also equal 9.75. So we can say it's greater than or equal to. And what rounds down to 9.8? That's 9.85. Anything up to 9.85 rounds down to 9.8, but 9.85 itself rounds up. So we can only say x is less than 9.85 for 2 marks there. Question 6 says, here is a rectangle. The length of the rectangle is 7 centimeters longer than the width of the rectangle. Okay, so we have a relationship here, and if we say the width is x, then we can say the length is 7 centimeters longer than the width, so that will be x plus 7. The second part says 4 of these rectangles are used to make this 8-sided shape. The perimeter of the 8-sided shape is 70 centimeters. Work out the area of the 8-sided shape. Okay, so here we've got one unknown, and we're told that the perimeter will equal 70. So I feel like we'll be able to make an equation with x in it that will equal 70, and that will allow us to solve for x. So let's firstly fill in the lengths and widths on this diagram. So we know that width is x, and the length is x plus 7. And this will be x, and this will be x plus 7, and this will be x plus 7, this will be x, and this will be x plus 7. Now we need to find these lengths in here as well. So if this is x, this width, and the whole thing is x plus 7, this length in here will be x plus 7 minus x. So x plus 7 minus x, that just leaves you with 7. So those little lengths are 7 each, 7 centimeters each. Now what we need to do is to add all of those lengths up, and if we add all of them up, we can say they equal 70. So let's first make an equation. So let's take all of the x's, and we've got 1, 2, 3, 4 x's. So I'm just going to say 4x plus x plus 7, x plus 7, x plus 7, x plus 7. There's 4 of those. So 4 lots of x plus 7, and then 2 lots of 7, 14. If I add all those together, that equals 70. Alright, so here I've created my equation. Now I just need to solve for x. So let's go ahead and expand those brackets. So we've got 4x plus 28 plus 14 equals 70. And then 8x plus 42 equals 70. And then 8x equals 28. So I've just subtracted that 42 from this side. And then x equals 28 divided by 8, that leaves you with 3.5 centimeters. So I've worked out what x equals. Also the length is x plus 7, remember? So the length will be 3.5 plus 7, that will be 10.5 centimeters. And now I can work out the area of one rectangle. The area of one rectangle, if I multiply the length times the width, 3.5 times 10.5, and that will give me 36.75 centimeters squared. And now what they want is the area of the 8-sided shape. So in this 8-sided shape, I've got 1, 2, 3, 4 rectangles. So the area will equal 36.75 times 4. And that gives me a total area of 147 centimeters squared. Surprisingly, this is a 5-mark question. So if you manage to get through that, well done, you just earned yourself 5 marks. Question 7 says, work out 13.8 times 10 to the power of 7 multiplied by 5.4 times 10 to the minus 12. Give your answer as an ordinary number. Okay, so as this is a calculator paper, this is not too challenging. One way you could do it is to say that 13.8 times 5.4 multiplied by 10 to the minus 5 will give you the answer. If you do that calculation, you get 74.52 times 10 to the minus 5. And then you can go ahead and count back with the decimal place, and you get 0.007452 for 2 marks. Or you could just put that straight into your calculator and you'd be fine. Question 8 says, when a drawing pin is dropped, it can land down, point down, or point up. Lucy, Mel, and Tom each dropped the drawing pin a number of times. The table shows the number of times a drawing pin landed point down and the number of times a drawing pin landed point up for each person. Okay, so here we've got a table, and we've got Lucy dropping the pin, Mel dropping the pin, and Tom dropping it. And Rachel is going to drop the drawing pin once. Whose result will give the best estimate for the probability that the drawing pin will land point up? Give a reason for your answer. So usually in tests involving probability, the more experiments or the more tests you do, the better estimate you get out of that experiment. So here we can add up the amount of times each person drops the pin, and if we can see, so if we add those up, Lucy's dropped it 45 times, Mel's dropped it 80 times, and Tom's dropped it 25 times. So here Mel's probability will give the best estimate as she's done the most tests. So we can say Mel's results will give the best estimate as she did the most tests. For 1 mark. The second part of this question says, Stuart is going to drop the drawing pin twice. Use all the results in the table to work out an estimate for the probability that the drawing pin will land point up the first time and point down the second time. So keywords there, point up the first time, point down the second time. So let's have a look at this table again. And if we're using all of the experiments, we can add up the amount of times it landed point down. So we add all of those up and we get 100. And the number of times it landed point up, and we get 50. So already we can see it's more likely to land point down if we drop the drawing pin. And in total they did 150 tests. What this tells us is that based on this experiment, there's 100 over 150 chance of it landing point down and 50 over 150 chance of it landing point up. So we can say the probability of landing down is 100 over 150, which is the same thing as 2/3, and the probability of landing point up is 50 over 100, which is 1/3. Now, if we're taking the chance of it landing point up the first time and point down the second time, we can take the probability of it landing point up, 1/3, then multiply it by the probability of it landing point down the second time. So what we end up with is 1/3 times 2/3, and if you want to check this, you can draw a quick probability tree using the drops and the probabilities of it landing each way, and you'll see that it comes out to 1/3 times 2/3, and that gives you 2 over 9 as the probability of it landing point up and then point down. Okay, on to question 9. Question 9 says, Jack bought a new boat for £12,500. The value V of Jack's boat at the end of n years is given by the formula V equals 12,500 times 0.85 to the power of n. At the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? Okay, so the value of the boat when it was new was 12,500, and we're taking the current value as the new value multiplied by this number here, 0.85 to the power of n years. So if we've got 50% of the value of the boat, we need to multiply 12,500 by something less than 50% or 0.5. So this part of the equation needs to be less than 0.5, basically. So we can say that 0.85 to the power of n needs to be less than 0.5. And then we can use trial and error. So take a guess at what it could be. So we could say that 0.5 to the power of 4, you could work that out and see what you get. And if you do that calculation, you get 0.522, etc. And that's just above 0.5. So what we want is to go down a bit further. So if we times 0.85 to the power of 5, by the way, if this exponent goes up, the answer will go down, as this is a decimal. So we get, if we do 0.85 to the power of 5, we get 0.4437, etc. So what this is telling us is that after 5 years, the value of the boat has dropped below 50%. So this is the first time, this will be the first year in which that does so. So we can say that the answer there is 5 years. Okay, the second part of this question says the savings account pays interest at a rate of R% per year. Jack invests 5,500 in the account for 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.2. Work out the value of R. Okay, so firstly, we can recognize what information we're given here. So we say that the principal is 5,500. And we're not given the rate, but we are told the interest that he's paid in this part. So this is going to give us the amount of interest that he earned on his principal. Because we're told that the tax rate is 40%, so therefore what he's left with is 60% of the interest. 60% of the interest is equal to £79.20. So using that fact, we can say 100% of the interest will equal 60% divided by 60 to give 1% and then multiplied by 100. Another way to write that is to take that 60%, multiply it by 100 over 60, and that gives you the 100%. And if you do that calculation, you get £132. So we know that interest equals £132 on this investment. And what we need to find is the rate. So what rate did he invest in? Well, if we take the interest and add it to what he started with, add those two together, we get 5,632, and that gives us the value at the end of the year. As this was the interest, this was the amount of interest, this is what he started with, so this is the amount he ends up with at the end of the year. And then using the compound interest formula, which looks like this, we can say that what he ends up with at the end of the year should equal 5,500 multiplied by 1 plus the rate to the power of the number of years. In this case, it's just 1. So this allows us, using this formula, this will allow us to find R if we rearrange to find R here. So firstly, divide 5,632 by 5,500. And if you do that calculation, you get 1.024. And as this is 1 plus R to the power of 1, I can just write it as 1 plus R. And then R is going to be this, subtract 1. So this is going to be 0.024. So this tells us the rate is 0.024 or 2.4%. Just multiply that by 100 to get the percentage. And that's question 9 for 3 marks. Question 10 says there are only blue counters, yellow counters, and green counters in a bag. A counter is taken at random from the bag. The the table shows the probabilities of getting a blue counter or a yellow counter or a green counter. Work out the probability of getting a red counter. So one thing you should know about probabilities is they always need to add up to 1. So the probability of all of them happening should add up to 1. So therefore we can work out the probability of red by adding these up and taking them away from 1. And if you do that, they all add up to 0.95. So the probability of picking red is 0.05 for 1 mark. And then part B says, what is the least possible number of counters in the bag? You must give a reason for your answer. So let's just think about this carefully. So in a bag with counters in it, there needs to be whole numbers of counters. So there needs to be whole numbers of counters. And the lowest number of counters that I could have must belong to red, because this is the lowest probability of picking a red counter. So the red counters must be the smallest number. So what's the smallest possible amount of counters we could have in the bag of red with a red color? That must be 1. That's the smallest amount of red counters we could have. So if there's a 0.05 chance of picking a red counter and there's 1 counter in the bag, we can say that we can multiply that number by whatever it takes to get the probability of blue. So if I've multiplied 0.05 by 4, I get 0.2. So therefore there must be 4 blue counters in the bag if there's 1 red counter. And if there's double the probability of picking a green, there must be double the number of blue counters. So there must be 8 green counters, and then there's 0.05 less probability of picking a yellow counter than a green counter. So I can take 1 away from the number of green counters, and I must have 7 yellow counters. So just to explain your working out, you might say let the number of red counters equal 1. So therefore, based on the probabilities, blue counters must equal 4, and you could finish explaining that. And then we need to add all of those together. So we've got 1 red counter, 4 blue, 7 yellow, 8 green, and we've got 20 counters in total for 2 marks. Question 11 says the cumulative frequency graph shows the information about the weights of 60 potatoes. Okay, just let me zoom out a little bit here. Okay, so here we've got the weights and then the cumulative frequencies. So in total we had 60 potatoes, and the min weight was around 40, the maximum weight was about 80. Part A says use the graph to find an estimate of the median weight. So when we're given a cumulative frequency graph, the median can be found by halving the total frequency, and then what we can do to find the median weight is to draw a line from the median on the graph across to the graph itself, and then down to the x-axis. I can't get this line properly. There we go. And that gives us the median weight, or the middle weight. And if we look carefully, if I've drawn that a bit more accurately, that would land on 57. So here we can say straight off the graph the median is 57 grams. The second part of this question says, Jamil says 80 minus 40 equals 40, so the range of the weights is 40 grams. Is Jamil correct? You must give a reason for your answer. The problem with this graph is that we can't be certain that the maximum is exactly 80 and the minimum is exactly 40. So we're not sure that he could be correct. So no. So we could say no, as we are not certain of the max and min. And that's 1 mark. And then part C says show that less than 25% of the potatoes have a weight greater than 65 grams. So let's go back to the graph now and find 65 grams on the x-axis. So that's going to be here. And we want to show that less than 25% have a weight greater than 65 grams. So let's go up to the graph from 65 grams. And what this does is allow us to find how many potatoes there are greater than 65 grams. And then we can go across to the cumulative frequency. So what this tells us is that there are 49, because this is 49, the cumulative frequency, there are 49 potatoes in the range up to 65 grams. So how many potatoes are above 65 grams? Well, that's however many are in this section here, and that's 11. There are 11 potatoes greater than 65 grams. So then we need to show that 11 out of 60 as a percentage is less than 25%. So we can say 11 over 60 times 100, well, that's 18.3%. So that's clearly less than 25%, and that's question 11 for 4 marks. Question 12 says, Alan has 2 spinners, spinner A and spinner B. Each spinner can land on only red or white. The probability that spinner A will land on red is 0.25. The probability that spinner B will land on red is 0.6. The probability tree diagram shows this information. Okay, so we're given a tree diagram here, and the spinner A is represented by 0.25 for red and 0.75 for white, and the spinner B. The rest of the question says, Alan spins spinner A once and he spins spinner B once. He does this a number of times. The number of times both spinners land on red is 24. Work out an estimate for the number of times both spinners land on white. Okay, so he's spun the spinners a number of times. We're not told how many times, but we are told that it lands on red 24 times. So based on this tree diagram, we can work out the number of times he's spun it using these probabilities, because we can say the probability of it landing on red twice, probability of red and then red, must equal 0.25 times 0.6. And that gives us a probability of 0.15. And if it landed on red 24 times, 24 over the number of times he spun it must equal this probability, 0.15. They should represent the same probability. So we could say that x here, x will equal 24 if we rearrange that, 24 divided by 0.15. So the number of times it landed on red divided by the probability of it landing on red twice. And then we can see the number of times he spun them is 160. Okay, so now we know the total number of times he spun both spinners. And we know that the probability of landing on white and white is 0.75 times 0.4. So if we put that into a calculator, we get 0.3. So the probability of landing on white and then white again is 0.3. And then what we can do is simply multiply that by the number of times he spun it to get the probability of the number of times it lands on white, or an estimate of the number of times. So we can say 0.3 times 160. Calculate that, and that gives you 48. So an estimate for the number of times it lands on white is 48. And that's for 3 marks. Question 13 says write x squared plus 6x minus 7 in the form x plus a squared plus b, where a and b are integers. If you didn't know where to start on this question, then look up completing the square, as this is what is known as completing the square. Is to get equations into this form. So if you weren't sure about this question, then make sure you do some research on that topic, completing the square. So when you are completing the square, there's a process that you can follow, and basically what we need to do is to create a perfect square out of this equation, use and then add or subtract a number on the end to make it equal the same equation, or the same expression. So if we take x squared plus 6x minus 3, the first thing I want to do is to write that into two brackets. The way we do this is we take this middle value, 6x, and we half that to get the second number in the brackets. In this case, it'll be plus 3 and plus 3. And the reason I do that is to get that coefficient of x to be 6. So if you notice, if I expand this out again, I get x squared plus 3x, which is 6x, and then my last value will be 3 times 3, which is 9, and that's not minus 7. So in order to make plus 9 equal minus 7, I need to subtract something. In this case, I subtract 16 and I get minus 7. So I can take this factorization, x plus 3 times x plus 3, and subtract 16, and that will equal x squared plus 6x minus 7. And so now I've got this nice factorization with something on the end, and then I can say all of this is going to equal, as this is a perfect square, I can say that's going to be x plus 3 squared minus 16. And what we've done there is to put it in the form x plus a squared plus b. So a is equal to 3 and b is equal to minus 16. And that's for 2 marks. Okay, question 14 says cone A and cone B are mathematically similar. The ratio of the volume of cone A to the volume of cone B is 27 to 8. The surface area of cone A is 297 centimeters squared. Show that the surface area of cone B is 132 centimeters squared. Now there's a little fact that if you know it in this question, it helps a lot and it saves you a lot of working out. And first I'm going to state that fact, and then I'm going to show you why that works. So if you know that the ratio of the volumes, so we know the ratio of the volumes, so we can say that V, the volume of A over the volume of B, equals 27 over 8. And we know the cones are similar, then the ratio of the sides, let's take one measurement in the cone, let's say the radius of A over the radius of B, that ratio will be the cubed root of the ratio of the volumes. So if you know that, this makes the question quite a simple process. Let me just explain to you why that works. So we'll take the volume of a cone formula, which is a third pi r squared h. And we know that the ratios of the volumes is 27 to 8. So we can say the volume of A can be given by this formula. So a third pi r A squared multiplied by HA, not squared, HA, divided by a third pi r the radius of B squared times the height of B equals 27 over 8. Now, let's do some cancelling, some simplifying. Cancel this firstly because they're the same value. And what we're left with is the radius of A squared times the height of A over the radius of B squared times the height of B equals 27 over 8. Now, because these cones are similar, all of these ratios, the ratio of the radius of A over the radius of B times the radius of A times over the radius of B times the height of A over the height of B, all of those are equal, and they all equal 27 over 8. So as these are all of the same number, in effect what we're saying is x cubed equals 27 over 8. So that x, that ratio of the sides, will be this ratio, the cubed root of this ratio. Okay, so that's a little side note as to why this works. So we can say the ratio of the sides is equal to the cubed root of the ratio of the volumes. So therefore the ratio of the sides is equal to 3 over 2, which is the cube root of 27 is 3 and the cube root of 8 is 2. So if we know the ratio of the sides is 3 over 2, then we can say that the ratio of the surface areas, surface area of A over the surface area of B, is the ratio of the sides squared, which equals 9 over 4. So we end up with a ratio of the surface areas of 9 over 4. And I'll leave that up to you if you can work out why that works as well. But here's the formula for the surface areas, which is pi r times the slant plus pi r squared. And if you take those surface areas in a similar method that I did for the volumes, you'll see that it works out to the fact that the ratio of the radiuses ends up to be squared. Okay, so if we take this ratio, we can say that the surface area of A equals, let's rearrange this a little bit. So the surface area of A equals 9 over 4 multiplied by the surface area of B. So therefore the surface area of B equals 4 over 9, because we need to effectively multiply this on the other side. So multiply by 4, divide by 9. Therefore the surface area of B will be 4/9 the surface area of A. So the surface area of B equals 4/9 of 297, and therefore you will get an answer of 132 centimeters squared. Centimeters squared, very important. Okay, so let's just go over again what I've done there. So I've taken the ratio of the volumes, I've taken the cube root of that ratio, and I've got the ratio of the sides, and I showed you why that worked. And then I take the ratio of the sides and I square that to get the ratio of the surface areas. I didn't show you why that works. I've left that up to you. See if you can work that out yourself using a similar method to what I did with the volumes compared to the ratio of the sides. And then I took that ratio of the surface areas to work out the surface area of B, which was 4/9 the surface area of A, which is 132. Okay, and that's only worth 3 marks. Okay, question 15 says, show that the equation x cubed plus 7x minus 5 equals 0 has a solution between x equals 0 and x equals 1. So this is a cubic. So if we were to graph this quickly, or do a quick sketch, a cubic generally looks like this, or has a shape like this. So it goes across and then down. So it's like a squiggly shape. Sometimes it can go up and then down like that as well. And sometimes it really has a really shallow dip in it. And when they're saying we need to show there's a solution between x equals 0 and x equals 1, if we look at this graph again, and we looked at the x-axis, x equals 0 is here and x equals 1, let's say it was here, we would need to show that there's a time when the graph crosses the x-axis between x equals 0 and x equals 1. And how do we do this? Well, we would say that this whole equation should be changing its value. So the y value should change. So when it's below the x-axis, it should have a negative value, and when it's above the x-axis, it should have a positive value. Also, if it's a cubic going this way, which you can have as well, maybe there will be a positive value and then a negative value. But however it works out, the values should change. So there should be a different sign for the value at x equals 0 and x equals 1. So let's go ahead and work these out. So if we let x equals 0, at x equals 0, x cubed plus 7x minus 5 equals, plug that in, 0 plus 0 minus 5, that equals minus 5. So at x equals 0, this equation has a negative value. At x equals 1, x cubed plus 7x minus 5 equals 1 plus 7 minus 5. That's going to be 8 minus 5, that will be 3. So you can see that the signs have changed. So in other words, the graph has crossed the x-axis at some point between these two values of x. So therefore we can say that yes, there is a solution. So as the signs changed, there is a solution. Okay, part B says show that the equation x cubed plus 7x minus 5 equals 0 can be arranged to give x equals 5 over x squared plus 7. So here you just need to do some algebra. So firstly, let's factorize the first part of that equation and take x out of x cubed and 7x. So that will be x bracket x squared plus 7 minus 5 equals 0. And then let's add 5 to the other side. So x bracket x squared plus 7 equals 5. And then let's divide this side by x squared plus 7. So we'll get x equals 5 over x squared plus 7. Then we end up with x equals 5 over x plus 7, and we're done for 2 marks. Part C says starting with x0, x sub 0 equals 1, use the iteration formula x sub n plus 1 equals 5 over x sub n squared plus 7 3 times to find an estimate for the solution of x cubed plus 7x minus 5 equals 0. So what we need to use here is an iteration formula to approximate or find an estimate for the solution. So starting at x sub 0 equals 1, x1 will equal basically this formula with x0 substituted into it. This is what this x n plus 1 stands for. If x0 equals 1, x sub 1 will equal 5 over x0 squared, so 1 squared plus 7. And that equals 5 over 8. And then you can write that as decimal if you want to. So we know the values now of x sub 0 and x sub 1. So for the next iteration we say x sub 1 equals 5 over 8. So x sub 2 will be 5 divided by, now we need to plug that into this formula again, 5 divided by 5 over 8 squared plus 7. And if you do that on your calculator, you get 0.67653277. So we know the value of x sub 2 now is that whole thing. I won't write it all out again, but make sure in your next iteration you're putting as many digits as you can, so at least 8 into the calculator to get an accurate answer. And then x sub 3 will be x2, all of this thing, x sub 2 squared plus 7. And then if you put all of that into a calculator, you get 0.67048483, and that goes on. And they haven't told us to round it off or anything like that, so I would just leave as many digits as you can for x3. So after iterating 3 times, that's our estimate there for the answer. Part D says by substituting your answer to part C into x cubed plus 7x minus 5, comment on the accuracy of your estimate for the solution to this equation. So what that's saying is take your estimate, plug it into this equation and see if it equals 0. So if we take that estimate for x sub 3, so we can say x sub 3 cubed plus 7 times x sub 3 minus 5 equals 0.301367. So I've taken that number, I've cubed it, and that's what I get. plus 7 times this number gives me 4.693138 minus 5. And if I do that calculation, that's basically, this is almost 5. 0.3 plus 4.69 is almost very close to 5. But if I do that calculation, I get minus 0.00549, and that goes on, which is approximately 0. So the estimate is close to 0. And depending on how accurate you've been in this stage, you might get a better estimate than this. But that's generally all you need to do for 2 marks for that question. Question 16 says the petrol consumption of a car in litres per 100 kilometers is given by the formula petrol consumption equals 100 times the number of litres divided by the number of kilometers travelled. Nathan's car travelled 148 kilometers, correct to 3 significant figures. The car used 11.8 litres of petrol, correct to 3 significant figures. Nathan says, my car used less than 8 litres of petrol per 100 kilometers. Could Nathan be wrong? You must show how you get to your answer. So he's saying that it uses less than 8 litres of petrol, and what we need to do is to show that he could be wrong or right. Now, if we look at the petrol consumption carefully, this is going to go up. This is going to go up if the number of litres of petrol used is higher and the number of kilometers travelled is lower. So what we want to do is to get the highest possible value of the litres of petrol used and the lowest possible value for the number of kilometers travelled. And because these are correct to 3 significant figures, we can take the upper bound for the litres of petrol used and the lower bound for the number of kilometers travelled. So we can say that the lower bound for the kilometers, lower bound of kilometers is equal to 147.5. So that to 3 significant figures, that would round to 148. And the upper bound of the petrol, will be 11.85, as that would round down to 11.8. So what we've done is taken the lowest possible value for the kilometers and the highest possible value for the petrol in order to find the maximum possible petrol consumption. And then we need to take these values, plug them into this formula, so we can say that the petrol consumption will equal 100 times 11.85 divided by 147.5, and if you do that calculation, you get 8.03389. So that's the maximum possible petrol consumption based on these numbers, and so therefore yes, he could be wrong. And that's for 3 marks. Question 17 says ABC and ADC are triangles. The area of triangle ADC is 56 meters squared. Work out the length of AB. Give your answer correct to 1 decimal place. Okay, so we need the length of AB, and we are given the area of ADC as 56 meters squared. Okay, turns out there are 3 formulas we need for this question. So the first formula we need is the sine rule for the area of a triangle, and that equals a half AC sine D. So that's saying if we take 2 sides and the angle in between it, we can find the area of a triangle. And what that's going to allow us to do is to find this side, CD. The other formulas we need are the cosine rule, which says that one side squared, a squared equals the other side squared minus 2 lots of BC cos of the angle you're given. So this allows you to find one side if you're given two other sides and an angle. And the other formula we need is the sine rule for the ratio of sides to angles, and that says the sine of A over A equals sine of B over B equals the sine of C over C. So even before you start, there are three formulas that you would need to be able to solve this problem. So if you weren't aware of those formulas, you won't have a chance of solving this problem. So let's try to break down how we're getting to find AB. There are some hints before you start. So you're given the area of triangle ADC. So the only reason they give you this area if you need to start over here somewhere. And if you think about it, if we can find the sides of this triangle ADC, we can find this side in here, AC, and then if we've got the side AC, we can use the sine rule to find x. So that's the basic process that we're going to follow here. So the first side we can find using the sine rule for the area of a triangle is CD. We can say that the area, 56, equals a half times 11 for this side, multiplied by the unknown side, CD, times the sine of the angle in between those, sine of 105. So then we can rearrange this formula to find CD. So if we, firstly, let's multiply 56 by 2, so we get 112 equals 11 times CD times sine of 105. And then if we divide this, so what we end up getting is CD equal to 112 divided by 11 times sine of 105. So I've just rearranged that formula. So the answer to that ends up being 10.54099938. Remember, when you're doing these types of problems, only round off at the very end. Until you get to the end, keep the number of decimal places as long as possible. So I've got the length for CD, and then I can use the cosine rule to find the length of AC. So the process to that looks something like this. So AC squared is equal to B squared, and in this case side B will be AD, so 11 squared plus CD squared, which was 10.54099938 squared, minus two lots of those numbers. So 2 times 11 times, I'm just going to write CD because I've run out of room, multiplied by the cosine of the angle in between those two sides, which is 105. So the cosine of 105. So now I have a formula that will allow me to find this the length of AC, this side in here, and I just need to work all of that out. So AC squared is going to equal 121 plus 111.113. That's rounded off a little bit, minus 231.9, that's 2 times 11 times CD, multiplied by the cosine of 105, which is minus 0.258 approximately. Okay, so then if I just keep on simplifying this, all of that works out to 292.133 approximately. So AC squared equals 292.133. So then if I take the square root of this, 292.133, I get 17.5 17.1 approximately. And we are talking about meters here. So AC in here is 17.1 meters. And now that I've got this side, I can use the sine rule and use these ratios to find x. So I can say that the sine of 118 divided by 17.1 should equal the sine of 48 over x. So the sine of 118 over 17.1 equals the sine of 48 over x. And then if you rearrange that, so work this out, sine of 118 divided by 17.1, and then divide that number by divide sine 48 by that number, and you'll get x. So x equals 14.3856, and round that off, and you get an answer of 14.4 meters. Okay, so quite a long process to that question, and 3 different formulas that you needed to know. So in general, quite a difficult question, and that's why that's worth 5 marks. So on to question 18. Question 18 says, here is a speed time graph for a train, and the speed is given in meters per second and the time in seconds, and we can see the graph going up like that. And part A says work out an estimate for the distance of the train travelled in the first 20 seconds. Use 4 strips of equal width. So when we're given a speed time graph, we can find the distance by finding the area under the curve. So the way we find the area under the curve is by breaking it up into sections and finding the area of each section. And this says to use 4 strips of equal width. So if we take the time up to 20 seconds, if we split that into 4 equal sections, that will be 5 seconds each. So let's take the area of this first part. That'll be a triangle with a base of 5 and a height of 2. So each 2 squares is worth 1 here. So to find the area of that triangle, I can just use the area of a triangle formula, and that will give me the area there. And then for this second part, up to 10 seconds, I'll actually end up with a trapezium. Now it's not going to be an exact number, and that's why it says estimate. That's why it says estimate here, because what we're doing, if you look closely, when we draw a straight line from 5 to 10, we're going a little bit above the graph. So we're including a tiny bit of area that's not under the graph itself. So what we end up with here is a trapezium, and we can find the area of a trapezium using the top side and the bottom side, which in this case is 5, and the height, which is 5. And then again, we can draw another trapezium from 5 seconds to 15 seconds, and again you'll see that we're including a little bit of space that's not actually under the graph. And the last one is from 10 to 20 seconds. Sorry, 15 to 20 seconds. Okay, so once we've drawn our 4 shapes, we can go ahead and find the areas. So the first one is base times height divided by 2, so that's going to be 5. The second area is 2 plus 5, in other words the top side plus the bottom side multiplied by height divided by 2. That's the area of a trapezium, and that gives you 17.5. Let me just write that out. So the area of a trapezium is equal to the top plus the bottom multiplied by height divided by 2. That's what I'm using to find these areas. The next one, it has the top is 5 and the bottom is 10 and the height is 5. So if I take those values, put them into this formula, for an area I get 37.5. And the last one, the top side is 10, the bottom is 18. So if you go across from here, you get 18, and the height is 5. So if I use those values in this equation, I get 70. So now I have the areas of these shapes. I can work out an estimate for the distance. So I can say 5 plus 17.5 plus 37.5. plus 70 will equal 130 meters. Okay, that's for 3 marks. So part B says, is your answer to A an underestimate or an overestimate of the actual distance of the train travelled? Give a reason for your answer. And as I've said, this is an overestimate because we're including a tiny bit of space here that's not included under the graph. So you can explain that in the question. So overestimate as I included some space not under the graph. And that's for 1 mark. Question 19 says, prove algebraically that the straight line with equation x minus 2y equals 10 is a tangent to the circle with equation x squared plus y squared equals 20. So what we know about a tangent to a circle is that the tangent only touches the circle in one place. So let's draw a quick diagram. So if we have a circle on a graph, if we have a tangent, let's say the tangent is down here somewhere, the tangent will just touch the circle in one place and it won't cross the circle anywhere else. So if this line is a tangent to the circle, there'll only be one value of x and y that satisfies those two equations. So let's take this equation x minus 2y equals 10 and rearrange it with one value on the left hand side. So we could say that for equation 1, x equals 10 plus 2y. Now if I take that x value, 10 plus 2y, and substitute it into the second equation, what I'll end up with is some values for y that will satisfy both the equations. Just like simultaneous equations, I'm basically solving two simultaneous equations here. But what I'm hoping for is one value of y, so I can say that this is a tangent. Because if this just turns out to have one value of y, then that means this line only touches the circle in one place. So let's go ahead and solve these simultaneous equations and see what we end up with. So taking this value for x and substituting it into this equation, I get 10 plus 2y squared plus y squared equals 20. And then what I can do is to solve this for y. So the first thing I need to do is to expand these brackets. So I get 10 plus 2y multiplied by 10 plus 2y plus y squared equals 20. And then expand them using FOIL. So firsts, outers, inners, lasts, plus y squared equals 20. And then simplify all of this. So I've got 5y squared plus 40y plus 100 equals 20. And then subtract that 20 from that side. So I've got 5y squared plus 40y plus 80 equals 0. Now, and then I can factorize out a 5. So if I divide all of those by 5, I get y squared plus 8y plus 16 equals 0. And then I can go ahead and factorize this equation into two brackets and find a value for y. So if I factorize that equation, what are two factors of 16? That will add to 8. That could be 4. So if I've got plus 4 in here and plus 4 in here, that will give me 8y. And multiplied together, that will give me 16. And so this tells me that there's only one possible value for y here. If this all equals 0, then y must equal minus 4. There's no other possible value for y that will satisfy that equation. So I can substitute that value back into the first equation. So x equals 10 plus 2 times minus 4. So x equals 10 minus 8, which is 2. So, and then what I can say is, as these two equations have only one point of intersection, then the line must be a tangent to the circle. Question 20 gives us a diagram and it says A, B, and C are points on the circumference of a circle center 0. AOB is the diameter of the circle. Prove that angle ACB is 90 degrees. You must not use any circle theorems in your proof. Okay, so this is actually quite an old question. This has come up in past papers before, but if you haven't seen this before, it can be quite difficult. If you are one of the lucky ones that have seen this before, then hopefully you didn't find this question too difficult. But let's go through the process as to how you're showing that this is 90 degrees. So we need to show that angle ACB is 90 degrees in this circle. So because we're told AB is the diameter and O is the center, we know that these lengths are equal. And we can go ahead and draw a radius from O to C, and by doing that we create two isosceles triangles. So let's give these angles some labels. So let's say that angle CAB is alpha and angle ACO must also equal alpha, as this is an isosceles triangle, and base angles in an isosceles triangle are equal. And then let's label this angle beta, and therefore this angle also must be beta for the same reason. Then what we need is to label these two angles in the center, so we can call this one gamma and this one theta. You can label them whatever you like, it's up to you. And what we want to do is to relate these angles in the center to these angles on the circumference. So let's come up with some equations to do that. So the first thing we can say is that because these angles are equal, we can say that 2 lots of beta plus theta must equal 180, or angles in a triangle. Therefore theta must equal 180 minus 2 beta. And then gamma must be 180 minus 2 alpha for the same reason. Then we also know that gamma plus theta equals 180, because angles on a straight line add up to 180. Now what we're going to do is to take these equations, these expressions, and substitute them into this formula. So what that's going to allow us to do is to relate alpha and beta together in one equation without gamma or theta. So if we take these values, so theta is equal to 180 times 2 beta, and gamma is equal to 180 minus 2 alpha. So 180 minus 2 alpha plus 180 minus 2 beta equals 180. And then we can simplify this. So 180 plus 180, that's 360. And then minus 2 alpha minus 2 beta equals 180. And then minus 2 alpha minus 2 beta equals minus 180. I've just subtracted that 360 from this side. And then we can factorize this, so take out a minus 2, alpha plus beta equals minus 180. And then divide this side by minus 2 to get rid of that minus 2, so we get alpha plus beta equals 90 degrees. And what we've shown there is, because we labeled these angles alpha and beta, alpha plus beta equals 90 degrees, therefore the angle ACB equals 90 degrees, equals the angle ACB. Question 21 gives us a diagram and it says OAN, OMB and APB are straight lines. AN equals 2OA, M is the midpoint of OB, so that means they're equal. OA is the vector A and OB is the vector B. AP equals KAB, where K is a scalar quantity. So AP is in here, so we can kind of label that K. And then given that MPN is a straight line, find the value of K. So MPN is here. And AN is 2OA, so that means this must be 2A. And we need to find K. So where to start with this problem? You're given a number of relationships. You're told that AP is related to AB. You're told that OA is related to AN. But it's hard to see how they fit together. However, there is two relationships that you need to use. It is the vectors related to this straight line. But even if you weren't sure where this question is going, there are some clues in the question to allow you to make a start. So let me explain to you what those clues are. So the first thing is that you're given the vector A and the vector B, and you're asked to find K. So what you could do to start off with is to relate K to the vectors A and B. So using the vectors A and B, we can find an equation for AB. So to get from A to B, we can add the vector B and subtract A. So this is B and this is minus A, and we get to B. So we can say AB is B minus A. And then therefore we know that AP is K lots of AB, so AP can be written as K multiplied by B minus A. Okay, so we've related to K to the two vectors we're given. Okay, that's a good start. What else can we do? Well, we're told the other clue in the question is that MPN is a straight line. Well, the thing we know about vectors is that vectors have a size and a direction. So let's say we have some vector x, and we know the size and the direction of x, and we're given some other vector, and we're told it's in the same direction. So in other words, we already kind of know what this vector is, and we know that it's some multiple of x. We don't know the size yet, but we do know the direction. So we know that this second vector must be something multiplied by x. So we can use that fact in order to help us solve this problem. And the way we can do that is we can relate Mn to Pn. So we can say that Mn must be some multiple of Pn because they're both on a straight line. And because we know that Mn can be written in terms of B and A, and Pn can also be written in terms of B and A as well now, that will give us effectively two equations related to each other which we can solve for K. So let's go ahead and start this process. So Mn, the vector Mn, will equal minus a half b, because this is a half b in here, so minus a half b to O and then plus 3a. So we have a vector for Mn, and Pn will be Pa plus 2a. Pa is just the reverse of AP, so that's going to be negative KB minus A plus 2a. Okay, so now we have two vectors which we can relate to each other based on the fact that they're on a straight line. So Mn must be a multiple of Pn as they're on a straight line. So the first thing I want to do here is to rearrange Pn so it's in the form of Mn. So in other words, it's in the form something B plus something A. and then I can relate the coefficients of b and the coefficient of a in order to solve for k. So let me show you what I mean by that. So I can say that Pn equals minus kb plus ka plus 2a. So I've just expanded those brackets. And then this is going to be equal to minus kb plus, if I factorize a out of that, I get k plus 2a. Okay, so what I've done by putting Pn into this form is to create a set of simultaneous equations. So because I know that Mn is a multiple of Pn, minus k times something must equal minus a half, and k plus 2 multiplied by something must equal 3. So let me write those equations down. So minus a k multiplied by something must equal minus a half. And k plus 2 times something must equal 3. So I've created a set of simultaneous equations with two unknowns, and now I can solve for k. So let's say that x equals 3 on k plus 2. So therefore, minus a k multiplied by 3 over k plus 2 equals minus a half. So therefore, minus 3k equals minus a half times k plus 2. I'm going to get rid of the negatives here by effectively dividing everything by -1. So this is going to be 3k equal to a half k plus 2. So then 3k equals k on 2 plus 1. So, and then I'm going to subtract that k on 2 from this side. So 2.5 k equals 1, and then so therefore so another way of writing 2.5 is 5 on 2, k equals 1, so therefore k must equal 2 on 5. And that's your final answer for that question, k equals 2 over 5. Let me just go over again the steps that I used. So firstly, my first step was to relate k to b and a, which I did with the vector AP. Then I took the relationships that I was told. So I was told that AN was 2OA, and I related MN, the vector MN, to PN by some multiple x. What that gave me was a set of simultaneous equations which I could solve for k. Let me just say that out of the 6 exams from 2017 I have reviewed so far, this was probably the hardest one. And question 21 is probably one of the hardest questions in the 6 exams. Other than that, that's the end of this video. Good luck with your revision, good luck with mock exams if they're coming up. I hope this was a helpful video. Please leave a like if you appreciated this video, and leave a comment letting me know what you think. Other than that, I'll see you in the next video. So bye for now.